Hi guys, I hope I'm audible, so it's good. Okay, thank you for choosing this session over the others. I know you all had a choice, so firstly, thank you for that. I'll do my best. And the way I structure this presentation is the first half of the presentation I'll be focusing on classical software application security, and the second half I'll be focusing on AI aspects. You know, there must be an AI element to every presentation, right? So I'll talk about AI later half. And a bit of disclaimer, so if I take out the name of any vendor, it's just because I personally tried that product and I like it and I'm talking about that. It's not because I'm not paid by any vendor or anything. I'm just planning to share my experience of different tools, best practices, or anything with you guys. Okay, it's just my view. Okay, a bit about my company. I'm not from sales or marketing, I'm from engineering. So just to let you know, that's the good part of the RSA, where you'll see different companies, right? Thales works in aerospace, defense, and cybersecurity. It's across various customers, 77,000 employees, so it's not a small company. Over a good amount of revenues as well. Okay. Anyway, the software supply chain security. You know, I was walking around to talk to different people around this conference, and I said, what first comes to your mind when I give you this term? People saying, is it that SBOM stuff? All right, SBOM is not the only thing that we'll talk about here, so we'll talk holistically across many things of the supply chain security. I've spent nearly 20 years in AppSec, only passionate about that, so I'll give you my best of this talk. So firstly, evolution of cyber attacks. Why are we newly calling these cyber attacks into a different things called software supply chain security? Historically, you have seen an attacker attacking something that is accessible, like a web application or a network or a host operating systems or a hardware that is actually deployed and being operated, right? But that has changed to attacking more supply chain of everything, in my opinion, which means originally it's no more in live in production. That's not the point, because maybe defense mechanisms have grown. It's more stronger and stronger with time. So attackers thought that why not I take the supply chain route to attack the things, okay? So for example, let's take our phones, okay? So we all have phones and we know that, all right, my goal is to attack the data in the phone, okay? So maybe people have put some nice face IDs, and it's more harder to attack something that's deployed in production rather than going it. We know that every device has lots of components involved into it, and probably I need to see if there is a way I can attack that component, or I can attack the component provider to be able to put something like a spyware on something into the device that will eventually go to the actual guy, and then I can get that assets, right? So that was the whole thing of cyber attack. So just explaining the same thing, there is an attacker who wants to attack the supplier or the supplier of the suppliers to be able to, which goes into the customer who has the assets, and that assets will be coming back to the attacker. This is the broader view of the entire supply chain system, but we'll apply this more and more to software. Okay, I'm not talking about the hardware stuff or the other supply chain related things, but purely software related supply chain. Okay, so what exactly are the attackers attacking in the previous diagram that you see in that supply things? You see it could be data, it could be service, it could be component, a library, which is different. Components can be a bunch of libraries. It could be binary code, process, configuration. They are the things that are being attacked as part of the supplier delivered ones. So if a supplier is delivering data, like a CSV file, a JSON file, that could be attacked. And there is a kind of a notion that people always assume software supply chain security means it's only for the development environment. Not necessarily. It can also be in production. That means if I get a file dynamically in my production environment that I'm consuming to deliver a functionality to an user, there is a risk of supply chain there, because something that is not in my control, somebody else is doing. So supply chain security in software not necessarily is linked to development all the time, okay? Anything that is beyond your control, and you get a service or a product or a code or any of these from in runtime in production, you have a concern of supply chain in your point. So what are the attack techniques used to attack those? So I need the code, I need the people. So either attackers have so many options. They can go for malware infection, which is the growing concern in the last 2-3 years. This is not new. Supply chain problems have existed for many decades, probably like few decades now. But the point is, it's growing in the last 2 to 3 years, how malware can be put into components. which you have seen in everywhere, like our phones are embedded with spywares, right? It is possible. Same way in softwares or components that we download as developers can be having malware. They use social engineering techniques. Of course, in order to attack a real nation-state act will include social engineering, brute force, and all of these attacks. Physical attacks, rubber duckies, I think you know that the USB devices people put and part of all of that. So there are various techniques people use, and they attack all of the previous things that I showed. Some of the widely known supply, I don't want to dig into any of these right now because it's for those companies to address, but understand this is not new. It really happened. A lot of companies have been a victim of this situation. They got attacked and they are in trouble for the supply chain things. Every company in this world, every organization, every university, everything that you take, there is a supply chain for them. So everybody must be concerned, in my opinion. And like one of the leaders said, every company is a software company in the world, right? So everybody is a software, then every software has supply chain. So every software supply chain is a bigger concern for every organization, actually, right? So firstly, before digging into this, I want to talk about the attack surface. Where exactly is the attack surface in my organization? Okay, I understand there is a concern in the global market, but what is the attack surface to me? So sometimes people think, is it just the third-party libraries that developers use? Is it the jar file, DLLs, or RPMs, or all of these things that I download? That's not the only point from, but the attack surface, let's start with source code, okay? That is where most often it starts. So you have a third-party library compromise. You have malware insertion, code tampering. That is one good point where you can be attacked. Or the build systems, sorry. The CI/CD build systems where you will see all these kind of cross-build injection attacks. If attackers are able to attack your build systems, they want to modify and they want to take control of your software artifact that they are delivering. So if you are able to deliver a software binary or a final component of your software to your customers, the attackers want to get into the CI/CD build systems. Or you know, some of these attacks we can speak about that, but there are also source control systems like Git repositories, Mercurial, Subversion you have seen as software development where things can be attacked. Like I'll also mention about repo jacking and brand jacking in a while. There can also be attacks on the package managers, which means like JFrog repository, Nexus repository, where or Docker hub.docker.com, where you store your software containers or software images or binaries, wherever you store. Even those can be attacked in a way to promote supply chain attacks. Okay, so some of these are there. For example, repo jacking. It's like taking over a good repository into their control, maybe because there is no 2FA enabled or anything. Or brand jacking, creating like a fake image of google.com with 10 zeros into it, so that it's not as silly as that, but generally taking over genuine ones and creating fake ones. Dependency confusion, I don't know how many have heard this, but it has become a growing concern as well. If you are a developer and if you have put Docker files, how many of you write Docker files here? Any developer in the room? So who say from this base image? So that's the first keyword you generally use. You take a base image and then you build images out of that, right? So in the base image, sometimes I see people saying from Ubuntu latest. So they use the word latest assuming that it's good, I want to take the latest available in my build. But the problem is when in the actual public repository, if the attacker has compromised the public repository and they put a malware-based Ubuntu image in that, you are becoming vulnerable to get that malicious image into your network. So you cannot use old version of the image because it has too many vulnerabilities. You cannot use latest image because it has supply chain concerns. So yeah, that's the depending confusion, because sometimes there is a version conflict between local ones and the remote ones. A lot of these things exist. And continuing on the attack surface, you also have on the container supply chain, the orchestration supply chain, the cloud supply chain, the vendor supply chain, everywhere there is an attack surface for the attackers to get in. And beyond this, even a developer workstation. For example, if you use Eclipse or VS Code or any IDE platforms where developers write code, you have plugins for it. So everything is being downloaded from the internet, right? So that is another attack surface where attackers can come in. And sometimes our CISO was worried about when we talk about supply chain security. That means that even developer workstations must be as secure as production environment these days. Because everywhere attackers are trying to come in, they want to put malware like spywares, virus, worms, Trojans, everything that you can think of. Right? These are some of the attack surface. I don't mean to say they are really comprehensive, but some of those which we have observed with time, especially our company Thales has been a lot on this supply chain things. Some of the key frameworks I want to put together as one shot based on my experience of working with all of these. Starting with Sigstore, great company which is giving you a lot of open source tools like Rekor for logs and monitoring, and for cosign for signing anything. Like you want to sign a file star.star, whatever the format is. Or if it is a container, you can sign a container. SLSA, a good framework for supply chain levels for software attestation or artifact something, which has 4 levels, level 0 to level 3, which talks about on a build situation right now. I think the SLSA 1.0 is limiting to build situation of your platform, where how well you can do the integrity aspects of your CI/CD. Microsoft S2CTF, I think they donated it now to OpenSSF, so it's probably part of the Sigstore as well now. Different frameworks, you can look at this. Even OWASP, software component verification standard, I like this because of good requirements on SBOMs and the versionings that it's a good requirement document as well. Google's software delivery shield, I like this as well because I think it's tightly linked to the cloud, GCP cloud if you're using it. They also talk about source threats, build threats, packaging threats, and the dependency threats and everything. So good references that you want to take a look at if you want. So historically, we have seen OWASP's top 10, right? OWASP top 10 is so common. I've seen from 2003 to 2023, so many OWASP top 10 has evolved. So people often think OWASP top 10 is one thing, but it's actually not. If you have an OWASP top 10 for Docker, for serverless, to cloud, to Kubernetes, to LLMs, to everything. So in all of this, there is an element of supply chain security. People have been speaking about supply chain security for ages now. It's not new, but just after COVID, there has been a surge of malicious components, so people are more concerned right now. Just talking about software components a little bit there, and it is often, no supply chain talk is really fulfilled without this slide, which I like, where people often see that, hey, there is a CVE that I downloaded a Log4j, Apache Log4j, for example. I'm using this version of the Log4j. It has this CVE, which is vulnerable. So I need to fix that because it has a CVSS 10. It's important to me. Vulnerability is important, but the bigger problem is malicious. The thing is, in vulnerability, you have a standard like CVSS, which says, oh, there is some threat that is important to me, like which is ranked on 0 to 10, which is important. But in malicious, there is no standard. Attackers can write a piece of Python code or a PowerShell code and can put into any component, and for example, like delete your C drive once you have the jar file downloaded. And there is no standard that can describe the nature of this. Probably it will be seen as a functionality. It's really hard to explain. You have to understand whether it is really a virus or is it functionality. It's hard to detect some things like this. So malicious libraries are increasing. They are intentionally designed. I believe malicious libraries are more important than vulnerable components. Vulnerability, it's a concern only if somebody exploits it. But malicious, you don't need to exploit it. It runs because that's what it's designed for. There's a piece of code that will run, so it's more important. So for example, you see, this has been an example that has always given in NPMs all the time, like how every company is trying to explain that components exist in these repositories where there is a same malware found components in one of the NPM libraries, and when they say, hey, the same library, they don't have a standard to express this, there is no CVSS or NVD database that can talk about malicious components, so everybody's trying to put their own identifier for the same problem. So today, most commercial companies, that's one thing I like about the commercial companies like the SCA tools. Google's OSV scanner, it's an open source tool. It's an interesting SCA tool you want to try. It also reports malicious components on top of vulnerable components. I like the Sonatype Nexus lifecycle, the Black Duck tools, Sonatype Nexus. I personally like it for Java and .NET point of view. Black Duck more for C, C++. There are other good tools like Oligo Security, Seal Security. I've seen them. I'm just hearing great tools about SCA. They are all about analyzing these libraries, third-party components to be used, something to be used. One thing that our organization does, and I believe every organization probably already has it or should do it, is a vetting process when you're going for a third-party components, which means a process in place that your developer is not totally free to download any component, any library, whatever they want from whatever they source. You need to have a proper vetting process, how you can select the component. Don't let a Log4j being downloaded from an unknown source, whatever location they want. So it has to be properly understood. So I don't want to dig into these details, but it's a good reference if you wanted to. So the big question, I want to use Log4j, I'm a developer, but which version to use? So this has been a big question to developers. So if you're a software developer, you'll understand what I'm saying. If I use a too old version, I have vulnerabilities. If I have too latest version, I have a supply chain risk, because some attacker in the internet will put a malicious thing on that component, and as a developer, I have a concern here, right? So that is where the concept of dependency pinning is coming. For example, you pinpoint the version which your developers must use, because it is probably well tested in your environment and it works. So there is a debate whether dependency pinning is good or bad. I'll say it's worth it rather than just using completely latest versions. I don't want to leave my system to the risk of supply chain, so I'll always pinpoint to the most latest available version rather than using the word latest. I always see that if somebody is using latest keyword, and today if I go to GitHub, there are so many applications just using latest. I believe they're all vulnerable to supply chain concerns. Okay, SBOM. SBOM, very important point. It originally started with the intention of transparency. For example, you buy a toothpaste, you will see, you look at on the back, what are the key ingredients it is made of. I want to know what are the ingredients in this product that I buy before buying it. Otherwise, there's no transparency in it. I assume it's good because it's made by a great company or anything. That was the original intent, but also used for integrity purposes. That means if a company makes a product and it confirms that these are the components that they used at the time of creation, somebody using the product will be able to verify that, oh, these are the components were used at the time of creation, so somebody did not alter it in the supply chain, so that is still applicable to me at the time of using the software. That was the point about SBOM. So we have lots of SBOM thanks to Cyclone DX with SBOM, SAS BOMs, hardware, operational, ML BOMs, everything. The way it has evolved is right now it not just talks about the components. Components are important. What are the components in the software, the hashes and everything, but it also talks about package locations, like from where did the developer download it. Did you download from Maven repository or NuGet repository? You have to specifically tell that in the SBOM file through a package URL or a software ID. The assembly information, which is the nested components, the components of the components and everything. Provenance, the other information, packaging and distribution. Interesting is the vulnerability exploitability exchange. What we are doing in our organization is I make a software binary, and I know that I'm using a bunch of components in it, but one of the component has CVSS 10, but I am not using the vulnerable API of that component, but I need to express this to my customers. Today, how do you do that? But your customer takes the product and probably scans it and finds a CVSS 10 in it, and they are screaming at you saying, hey, you have a vulnerable component in your software. This is a great place where in SBOM with Vex, you can actually describe that I've tested this component has CVSS 10, but I am not vulnerable to it because I'm not using that API of that vulnerable component. Does it make sense? So the Vex is a way you communicate to people. And also if there is any publicly available exploit of that component, you actually describe that in the Vex. It's more transparency. What components exist, what vulnerabilities exist, and what are the audits that I did which I did not address, so that your customer can manage those on their environment, right? So that builds trust as well, and I like that. Another thing that I want to show you is also this interesting one with Intoto. Anybody heard about Intoto here? If you are building your softwares with CI/CD platforms, and today there is no mechanism, either you're using Jenkins, GitLab, GitHub, the pipelines or the GitHub Actions or anything, where you can limit what the pipeline can do in an authorized way. So for example, if there is a malware component downloaded by a developer unknowingly in the build platform, probably as part of a data exfiltration, an outbound call is happening from your build system. But with Intoto framework, you can limit what can be performed by the build system. For example, if you say, I cannot allow HTTP calls to outside this machine because I didn't authorize it. So if a malware component comes into your build platform, it's technically restricted to make a communication outside. So it tells you with a root layout file what can be done on this build platform and what cannot be done as an authorization, technical authorization. It's a great way to limit all the technical capabilities on the build platform, so it's good. And cosign, of course, to be able to sign every software artifact and binary that you produce as part of the CI/CD build. Okay, I'm talking more from a development standpoint here. One of the things that I want to talk about is also the signing in a detailed way. So SBOMs are becoming larger and larger. They are becoming more bulkier with time. You know, Cyclone DX I think last month they released 1.6 version. They also added the attestations with cryptographic bombs and everything into that. I just see maybe few years down the line, SBOM is the new attack surface for the attackers because it's going to have a lot of information. So I see sometimes developers don't understand SBOM well, but they try to put every information in the SBOM in the name of transparency. So just for example, the new thing that got added as part of this is the attestation. So the way it was designed to be, for example, your team has got a set of developers and you have trained them on secure coding. So you want to claim to your customers that my team has been trained on secure coding in SBOM as a claim. That's an attestation you want to make to a customer. You can do that now thanks to the Cyclone DX 1.6 version with that attestations. So you can make any custom claims you want now with this one. So which also means that you need to sign everything. So the way SBOM signing will happen, if it is not already the case, is multiple signatures. Sometimes we don't develop the entire product by one team. There is a component developed by another team, probably another vendor, which I outsource. They give me components. I merge all of this into a big software binary and then deliver it, right? So we have to ask every company that delivers a component to produce SBOMs with multiple signatures like this. So signing this, individually signing that. So as of today, as I speak, I saw the ability of cosign. Have you heard about cosign, by the way? Some of you have heard about cosign tools, which is a good signing tool, but it does not support signing multiple signatures on within the file. So that's why as of today, I use a CD gen tool called Cyclone DX Generator CLI tool, which works on multiple signatures within the given SBOM. That means for every section of the SBOM, for the components part, for the attestation parts, for the provenance part, you can have multiple signatures generated like that. And then finally publish all the three, like the SBOM file, the signature, and the public keys used. This is a kind of process we are trying to put in place in our company as well with multiple signature process. So as I speak today, the good tool to use is still CDX Gen, which is Cyclone DX Generator. Okay, that's a good aspect of classical software supply chain security. Okay, I'll switch a little bit to the AI part because I've been researching on AI for the last few years, and I want to share my experience in regards to the software supply chain security. Okay, I'll not dig much beyond that scope, but it is an important. So firstly, when I put the pieces of cybersecurity and AI together, fundamentally, I know some of you are probably knowing this, but I just want to put it in a more, the way I learned it. So when I bring AI for cybersecurity, that means that cybersecurity is just a functionality where AI can be applied. AI can be applied to anything, right? Healthcare, telecom, banking, automobile, anywhere. So you can apply AI to cybersecurity as well. For example, let me give you, for example, if you have a bunch of PCAP files. PCAP files are all those sniffers, TCP dump, and Wireshark that you do, and you have a terabyte of PCAP files. And you find it so difficult to know out of these bunch of PCAP files, is there a data exfiltration happening? Maybe you will say, oh, let me push this to some kind of SIEM tools or somebody let it read it. It gives you a nice graph, but we need logically to quickly tell me, out of this terabyte of PCAP files, is there a data exfiltration happening, which is the IP address? I need to know exactly in faster. So AI is a good use case, and AI use cases exist a lot of that. Beyond that, but where I'm more interested in is putting cybersecurity for AI. That means I want to secure AI systems. So where I don't want to be attacking AI systems, I want to protect AI systems the way it works, right? So I'm more into the second aspects. For me, the first one is more I just recruit an AI guy, he will do the jobs, right? But anyway, so when I talk about cyber threats to machine learning, I personally understood this, which is twofold. And and this is my terminology, maybe it does not exist in the internet. I call it malware ML. The adversarial ML exists for years, everyone knows it. I see that people are confusing between these two terms, so I just thought I'll put it here. When malware ML is where attackers are using your data sets or machine learning models as a channel to push malware into your company. This is a general cybersecurity problem for years that we have. This is no different from anything that we know from past 20 plus years, where data sets and models are just another way to get into your network. That's it. If you download unknowing, untrusted models from Hugging Face or whatever, TensorFlow Hub or whatever repositories, you still have the same problem as downloading a PDF from an unknown source. It's the same thing. But the second one is adversarial ML. Adversarial ML is literally attacking the ML. That means I want to make sure the machine learning, let's take ChatGPT, I want to make sure if I ask a question like what's the capital of France, it should tell me Washington. I want to attack the model to misclassify things, to break the answers, to provide a wrong answers, or I want to able to do a lot of other things. So adversarial ML is attacking the machine learning. You can have an intersection between the two. That means I push malware to discover other models in the company and attack them as well, which is also possible and which is happening in the real world today. Okay? So in these two contexts, just talking about malware ML, Hugging Face, which is the most popular one, I shouldn't be only using their name, even Google's TensorFlow Hub, hub.tensorflow.com, just like hub.docker.com, it's a repository of all models, all data sets, many, many things that exist which are pre-trained models. Hugging Face has a great team. They actually analyze whether there is a malware in the models and everything. But I like this Product AI company. If you guys, anybody from Product AI, you should feel good. They have done analyzed about some few thousand models, and they're saying, yes, some of the models contain malware into it. That means the moment you download the model and try to load the model into your Python code, there is a malware that's running, which we saw in a proof of concept in our company. There are so many malicious models, so don't blindly use any model without it being really popular. But out of those, only 1,000 plus are really marked by unsafe by the Hugging Face security team. Today, you might say, hey, roughly that's out of 400K, only 4,000, which is 1%, are really malicious. I'm not worried. But the point is, it's growing very rapidly. Every day, malicious models are growing in Hugging Face, so people have to be more worried. So there is a supply chain problem, so don't just take because it's there in the Hugging Face, okay? So that's the supply chain security problem I'm trying to address. Companies are using, just like if you're a developer, you have Java, Spring, Struts, and all of these frameworks that you use. Even in machine learning, people use frameworks like TensorFlow, PyTorch, Keras, Scikit-learn, and all of these frameworks like Apache MNetNext. They are libraries and frameworks that developers use as Python, or mostly in Python, not much in R. But you have data sets that you download. You use pre-trained models to do your job. Like if you want to build a chatbot, maybe you are in some kind of real estate and you want a chatbot to show the pricing of your things that you want to sell. So people are taking the pre-training models and just tuning it with some information that they have and publishing without understanding the risks of just using the pre-trained models. So I want to dig a little bit technical onto this point here. So the point is there could be a lot of malicious code in any of those. If you just look at the Google's TensorFlow, if you look for CVE, there are so many CVEs on the previous versions of TensorFlow as well. 1.x especially has so many CVEs. But developers are still using TensorFlow 1.x. TensorFlow 2.x has already been released quite a long time anyway. So the point is, okay, when I switch to adversarial ML, now I'm not talking about the malicious aspect, but I'm talking about the adversarial aspect, which is attacking the models. It was very popular diagram. I thought I would rather reuse it rather than just creating it, which means I'm attacking the model. I'm attacking the data set, literally, as an attacker. The popular ones, there are so many attacks actually. I literally listed about 3,000 cyber attacks possible in the machine learning in a blog post that I wrote. But the most popular ones that I see, which most industries people are talking about, is these four: evasion, extraction, inference, and poisoning. I don't want to go into details at this stage, but it gives you an idea that people are attacking the models and the data sets. It's a great source from IBM's tool. Started off from there. But I want to go into one attack, just one. Literally a bit technical here. I apologize if you don't like it, but just one attack I want to talk about: evasion attack. Why I have to talk about this is to tell you the importance of securing your models that you download. So there is a bigger problem that you will see here. So firstly, what is an evasion attack? Evasion attack is anything I modify in an unauthorized or an incorrect way to fool the system to get something output. Like for example, there's an autonomous car that is driving and it sees a stop sign and it stops because there is a stop sign. But an attacker thinks, okay, let me put a sticker or something there on the stop sign, and probably the model does not understand in the autonomous car it is a stop sign and it will continue moving. This is a silly example that exists for a long time now. A bit more powerful example is which, when I put a sticker, people understand, oh, somebody is trying to be bad guy here. They want to fool the model, so there's no stop sign. Or if it is a school zone where the speed limit is just like 20, you have to go in 20 miles per hour. But people use a hologram with their phones and project as 200 miles per hour on a school zone. It'll race up fast because they think there's a speed limit of 200. So various things that you can think of, but they are all human readable. People can understand somebody is trying to attack. But there is a factor called epsilon, and if some of you don't know this, epsilon is a factor that determines the level of alteration I can do on the input. So if I put a lot of alteration onto the input, anybody human can see and understand something has changed here. But if I put it very low, then it works, attack does not work, it works perfectly. So let me give you an example in the number 7 here. So I sent a picture 7 to the model and say, can you make a prediction? It says it's 7. But my epsilon value, EPS value is 0.01. Now, as I increase my epsilon, there is a small perturbation or a disturbance that I created in the input. But at the time I created the epsilon value of 0.175, the disturbance is so much that the prediction now became 3. So now I understood that at what level of the epsilon my input will be kind of my attack works for the model, that it will misclassify. The model does not work anymore, right? So now I understood as an attacker that probably my epsilon is between 0.15 and 0.175. So this I need to do. Okay, what about this attack? Okay, we are talking about evasion attack. I understand that attackers understand the epsilon value and they will change it. What about this? That is where the point is in terms of open source models. I'm really against these open source models when I keep telling people, please don't blindly believe that just because a model exists in Hugging Face or anything. You have to understand attackers are able to analyze those models, at what point the model fails or misclassifies, they understand very well. So if you just use a model and use your own data, that means you are vulnerable to all those attackers, and attackers have already got that information. So I try to put all my research into a simple diagram here telling you from a high risk, medium and low risk. Of course, if you go with a proprietary model, it's very expensive. I mean, you need a lot of computing power, you need people, you need time. You need to invest on building your own model and you need to maintain it. I understand it's expensive, but it's secure. It's secure because your model is not accessible directly to an attacker. It's between you and your customers or your partners or anything, and it's probably a closed and protected model. So analyzing the model is really hard. So they don't know the epsilon value at which the model misbehaves. So going to a proprietary model is a secure approach. Do not assume that open source models means great. It's because every attacker understands at what point the model fails. Okay, this is just a summary of my my research. Anyway, talking about supply chain, I should definitely mention the work of OWASP here in terms of machine learning security and LLM security that they mentioned. Supply chains are always a part of these, like I said in the OWASP, right? So just digging into these two aspects. So what I did is I understood all the risks around this machine learning and supply chain and everything, and I thought I have to build some kind of framework. So of course there is a Google's Secure AI framework, there is a Microsoft Secure AI framework, everybody has published, so I thought why not me build something on my own. So I did it for Thales, and we are in the process of open sourcing this. So Thales has got a GitHub account, so you can go there, it's all open source. This is not yet open source, it's coming later this year, but I'm just getting some approvals from my management at this moment. But the point is, in this framework, we are talking about 5 different dimensions of securing machine learning. Focusing on data, focusing on model, platform. Platform, for example, model is just a pickle file that exists, but how do you expose the model? Maybe through a REST API, maybe through a web interface. All of that is the underlying platform with the operating system. Compliance aspects, everybody from NIST and European AI Act, everybody is pushing about securing AI aspects, right? The human, where exactly you need to involve human in the AI things, and what kind of awareness you need to bring to the developers, to every department working on the AI aspects. So the same framework, if I talk about all of those 5 things into 2 different segments. One is from goal, what exactly I need to achieve, and how do I achieve, what and how aspects of these 5. So I just put a brief point about our framework that we are publishing here. What exactly am I doing on data security? What exactly you need to be concerned on model and all of that? And what are the techniques? Now, let's take just one example. I'm not going to go into details. So if I say confidentiality aspect is important in data, which is training data, validation data, or inference data, whatever you call it. It's a CSV file or whatever it is. You're worried about, for example, confidentiality, and one of your techniques is encrypt. Okay, you need to encrypt. So you can build requirements around that. So you can build requirements around all of this. For example, one of them is also pen testing AI. So pen testing AI is different from classical pen testing, by the way. It's a lot of Python code here. And some of the tools which I liked, it's just my view. I'm not paid by any of these vendors to be able to put their name here. It's just I like it. Last RSA conference, I heard about the Azure Counterfeit when they spoke here. I really like the tool. If you take a model, for example, from Hugging Face, and you're worried that, hey, how is the security of this? Just put that to, it's an open source tool, put that to Counterfeit. It'll give you on a scale of 0 to 10 how good it is, roughly. It doesn't yet work on large language models. On small language models like SLMs, it's okay, but not big Llama or Bard, GPTs, not yet at that scale. Protect AI's models can, these are all open source. Everything that I listed here is an open source tool, so feel free to explore them. It's my recommendation. So closing note, CISOs want zero trust policies, but our developers just take whatever they want, so blind trust policy, kind of put this name. But the point also is about the attackers. They are growing a lot in supply chain. As we speak, they are obfuscating malicious code so that your scanners and everything don't discover them. They are writing scanner evasion codes, setting up custom exfiltration infrastructure, how they can export data from your infrastructure, like going over different systems and everything, hiding malwares into payload, into README files. Different things I have observed here. Okay, so just last 3 slides talking about what are my recommendations as me. I'm no expert or anything, but I just thought I'll share my best practices, which out of my experience to you. First thing, when you talk about software supply chain security, the first and foremost, have a good AppSec policy in place according to the industry. There is an ISO 27034 which we are compliant to and which we follow. There's a NIST document, BASIM document, OWASP, SAM, everything. Very important point in my opinion, your build systems, your dev systems must be as secure as production systems. In the past, we were like, oh, this is a dev system, it's okay, I don't have to be secure. That's not the time anymore. In supply chain security, your dev systems are production systems. Okay, so you have to harden your Jenkins, GitLab, GitHub, whatever, TeamCity, whatever build systems that you use. The plugins, the project, if you create a project on Jenkins, the configuration of the project, the pipeline configuration, the application security, everything around the way you build a software matters. It's as secure as production, it should be. Secure the development environments in terms of your developers. So if they are coding using some tools like Eclipse or Visual VS Code, make sure they are understanding the security concerns in supply chains, train them on these. And for example, an important point is signed commit. If you are familiar with Git, how many of you know Git here, architecture if you're a developer? So in Git, for example, you have 3 or 4 developers in a team. So the way Git configuration works is I can put my colleague's name and email and push the code. The Git server has no idea whether it is me or that person. And there's no authentication. There's only the way I just push the code from my local repository to the remote repository. I can put anybody's name unless you literally sign it. Sign the commit, then you are using a PKI infrastructure which digitally signed that it's literally me, and you will see on the Git server that there is a signed token. It's literally me who is pushing the code. So if you don't have all of this in place, attackers can take advantage, whether it is internal attacker or an external attacker. Okay. Another best practice is definitely talk about the secrets. Lots of secrets everywhere. People are hard coding passwords. So we used, this is where one of the things about Thales as well. By the way, you guys probably are familiar with Thales with recent acquisition we did with Imperva. Imperva is the big popular firewall that we have. So we provide HSIMs as well and KMS. I'm not doing a sales pitch here, but just telling you that we are popular in that market. Use some SEA tools to understand the malicious components. Don't just focus on the vulnerabilities. Please think about malicious components. This is more important than vulnerable components, in my opinion. Have a vetting process in place and make sure there is end of life is properly handled. I've seen cases where people use base images of Docker to build softwares, containers, and but they never update those because the author of the original base images has just left it. So look at the end of life images as well. Continuing on the best practices, implement software attestations, which means the way your build chain is happening. Make sure there is a full control of what it can do and what it cannot do. Digitally sign off that. Educate your developers on software supply chain security concerns, that the risks exist now, not just in production, but everywhere in the development environments. Okay, implement a secure AI/ML framework talking about AI and machine learning, and use those tools as needed. Thank you. Thank you. Any questions? Oh, yeah.
Thank you so much for sharing all of your knowledge. I felt like I just got, my brain is full. My question is sort of from a high level, 10,000 foot view. The SBOMs are supposed to ultimately give me, as a consumer of software, more confidence about what I'm consuming, right?
Right.
Do you think that's true, or is the SBOM just raise more questions than it answers?
In the process, we are in the transformation phase, in my opinion, where people don't have SBOMs in the past and now trying to publish SBOMs slowly. So in this process, there's a lot of confusion happening, what we can put and everything. I think it's a temporary problem, what you're raising. Eventually, when people understand the real intent of SBOM, which is both transparency and integrity aspect of the way it was built, what is inside the software and everything, and people understand more, then it'll probably slow down with time. So people should not be really concerned about SBOM. It is more a good thing people should do, in my opinion. Cheers.
So adding to the confusion question, given there are like 7 or 8 models of AI risk, there's multiple frameworks already for AI, securing AI, what's the value in N+1 framework that Thales is trying to build?
If you're talking about the defense frameworks, it's just another one. I don't believe.
But what's the differential value as opposed to adding to confusion?
No, right now, in my opinion, the whole world is in a research phase in terms of securing AI. There is no one good defense mechanism in place the way I research it. Everybody is talking about the attacks. The defense aspect is just a research work. So if I were you, I will research every framework published by every company to see what fits in my context, in my opinion. But in Thales context, we are just looking at our experience and analyzing whatever frameworks that exist, and we published our own framework. And we are yet to publish. But I'll just say it is just another information source for you to look at what is the right fit for your organization. If it makes sense. Yeah.
Hi, I loved your talk. I was very curious what you thought about potentially using, instead of multi-signatures, using multi-party computation. Where
Sorry, I couldn't hear.
So for SBOMs, right? So you mentioned the possibility with Cyclone DX of using multiple signatures to sign each section. I was curious what you thought about possibly using one signature that multiple people have to put their keys in to create.
Yes.
If that would be any better, any worse, just what you thought about it.
Yes. So if your concern is there are multiple private keys involved, and am I shooting my own shoe? No, the point is the reason we want to have multiple signatures is because the components coming from different sources, not within your team. So if you have outsourced one of the component or a functionality to be developed by another company, they are delivering it, they maintain the private key for the component they develop, and you have your own private key for the component you develop. So that is the reason it supports multiple signatures, not because. But if you have a team that's just developing end-to-end product on your side, you probably are good with one.
Fair enough. Thank you.
Cheers.
I hope.
Thank you, great presentation. So I have just 2 questions. So the first one regarding the secure AI ML framework. So does it have any privacy considerations? And for the second question is related to the proprietary models. So basically, although they have low risk, but still they can be targeted by customers because you might know some black box attack where only the user doesn't have access to the model, but he can like get some requests that can be malicious and then compromise the model.
I did not get your second question, but in terms of first question, the privacy, yes, it addresses in terms of 5 different things, the multi-part computation, federated learning, and homomorphic encryption and all of this. So yeah, we are in the process of publishing this in the open source. You can look at that.
Perfect. For the second question, it's just like for black box attack, because proprietary models, they don't have, the users or the customers, they don't have access to the model.
Right.
So it's going to be difficult for them to compromise it.
That's the idea.
But also they might be subject to target attack because in black box attack, usually the user doesn't have access, but he can send some request.
If they can access, if you have a way to reach the model.
Okay.
So I meant here in terms of closed model, which is delivered to us dedicated customers where you're not publicly exposing a model. But if you have a model like GPT, which is publicly exposed, doesn't matter it's open source or not, I can put a lots of queries. Like back in December 2023, there was an attack on GPT, and an attacker was able to download the entire weights and biases of a model just by putting millions of queries to that model.
Perfect.
If you expose your model, there is always a risk of recreating your model. That's a different problem.
Perfect. Thank you. Thank you
Cheers.
so much.
Cheers.
I have one.
Okay.
This is regarding the origin analysis.
Sorry?
Origin analysis.
Okay.
What I mean by that is, in the development, a lot of tools, SAST, DAST tools being used, but those tools are developed by people from certain countries. Okay, so if people from those certain countries, then there's a concerns raised here. How do you tackle that, and how do you do that in the?
No, if you are working in an industry where you have a regulation bound that you cannot use the tools beyond international tools or anything, then you have to find local tools. But in my opinion, we have tools that we just look at the attack vectors of the tools. The focus is on technology rather than where it is developed in our industry. So I am not regulated not to use a tool that is developed in another country, so I do not know that.
I see. Okay, thank you.
Cheers. Thank you. Thank you for joining.